Hi, so today I'll be doing a problem from the AP Physics 1 and AP Physics 2 course and exam description found on collegeboard.com. And the standard I'm targeting today is 5.D.2.2, and it says the student is able to plan data collection strategies to test the law of conservation of momentum in a two-object collision that is elastic or inelastic and analyze the resulting data graphically. So the problem reads, a group of students has two carts, A and B, with wheels that turn with negligible friction. The carts can travel along a straight horizontal track. Cart A has known mass ma. The students are asked to use a one-dimensional collision between the carts to determine the mass of cart B. Before the collision, cart A travels to the right and cart B is initially at rest, as shown above. After the collision, the carts stick together. So right off the bat, I can tell that this is an inelastic collision as the carts stick together after they collide. The first part asks us to describe an experimental procedure to determine the velocities of the carts before and after a collision, including all the additional equipment that we will need. So when it asks for determining velocity, what comes to mind when we hear that? So we're going to automatically think of how are we going to find the distance and how are we going to record the time, because we know that distance over time will give us the velocity. So the first thing that we're going to do is that we're going to mark off two distances on the track, one for cart A before the collision and one for the combined carts after the collision. We're going to give cart A an initial speed because we need the system to be moving. And we're also going to use a stopwatch to measure the time it takes for the carts to cross the marked distances. Speeds are distances divided by the times. This will give us the values that we need for velocity. Part B asks, there will be sources of error in the measurements taken in the experiment, both before and after the collision. For your experimental procedure, will the uncertainty in the uncalculated value of the mass of cart B be affected more by the error in the measurements taken before the collision or by those taken after the collision, or will it equally be affected by both sets of measurements? Justify your answer. So this question was a bit confusing to me at first. So the first thing I did was I wrote out this equation that represents the conservation of momentum. The reason I don't have this term here, that would be mb times vi, is because that the initial velocity of cart B is 0, so that term would cancel out, so there's no point in including it. So it's asking if the mass of cart B is going to be more affected by errors in this term or in this term. This term. So if I isolated MB, which would affect its value more? And just by looking at it, you can tell that the value of the final velocity will affect the mass more. If the measurement errors are the same magnitude, they will have a greater effect after the collision. The speed of the combined carts will be less than the initial speed of cart A. So errors of the same magnitude will be a greater percentage of the actual value after the collision. Part C asks, given MA equals 0.5 kg, use the graph to calculate the mass of cart B. Explicitly indicate the principles used in your calculations. So in order to find the mass of cart B, we're going to need a couple values. We're going to need mass and velocity because that's what's given in the equation. So looking at our graph, we can draw a best fit line. This represents before the collision and this represents after the collision. So I'm just going to go ahead and draw a best fit line to the best of my ability. And the next thing we're going to do is we're going to find the slope of these lines because, as you know, position over time will give us velocity both before the collision and after the collision. So initial velocity is at the point 0.9 and 1.4. So this is how we solve for velocity. It's just going to be distance over time. And we're going to do the same thing for our second best fit line. That's this area right here. That equates to 2/3 meters per second. The next thing we're going to do is coming back to that equation that we had initially, and we're going to plug in the values. So we know the mass of cart A is 1/2 kilogram, and we know that the initial velocity that we solved from the slope of our line was 14/9 meters per second. Our second velocity was 2/3 meters per second, and that happened after the collision, which is our final velocity. Solving this, you isolate the mass of B, and then we learn that the mass of B is equal to 2/3 of a kilogram. The next part of part D asks, the students are now asked to consider the kinetic energy changes in an elastic collision, specifically whether the initial values of one of the physical quantities affect the fraction of mechanical energy dissipated in the collision. How could we modify the experiment to investigate this question? So, what we could do is that we could vary the initial speed of cart A. Because as we know, if we vary the value of V, we're going to alter the value of our kinetic energy, and that's what we need to find. So we want to analyze, did the energy dissipated yield different values? So solving that, Ki minus Kf over Ki will help us to determine if the changes in our initial speed actually give us different values. And that concludes my video. Thank you for watching.